Lamai, can you all hear me? You all are not responding. That's why.
I can hear, teacher.
Okay. Do you all hear any background noise? Hari, okay. Okay. What I asked was, who are the newcomers to the class today? How the first day join with Lamai? Any newcomers today? Any newcomers today? Sanjana is a newcomer, okay. What about others? Yes, where did you say it, Sasheli? Lamai sent a link in the main chat for the whiteboard. Anya, Chalukya, Dihansa, Jituli, Joshua, Kushit, Jevindu, Ranmihi. Sanjana is new today. Sasheli, Shweta, Stephanie, Tarusha, Tatsarani. Hari, okay. We'll start. Where did we stop the last day? As you all know, Lamai, on the Independence Day, we have the extra class, right? 4th of February. We said 8, no? 8 a.m. ne api class apati no 4th of February. 8 a.m. or 7:30? 8, ne? Right, okay. Yes, Sashil, I actually moved to Mathura for like some further studies and work. But right now I'm in Colombo. I'm just going back and forth. Okay. We will start today's work. Can I know where we stopped last day, Lamai? I remember that we were talking about speed. My whiteboard note in the group. Unfortunately, I can't open WhatsApp from my laptop. So let me see. Whiteboard note තියෙනවානේ. හරි. අපි අන්තිමට කරලා තියෙන්නේ mean speed and then we have just started velocity. Is that right, everybody? We have just started velocity, right? Okay. Now we have also talked about velocity and we have said that velocity is displacement divided by time. Just like speed is distance divided by time. Okay. So, Munat Lianepa, just listen. Let's consider a motion. Right? අපි motion එකක් consider කරමු මෙන්න මෙහෙම. I'm going to draw a table like this. Or shall I just get this table from the textbook? I think that would be easier for us. මෙන්න මෙහෙම motion එකක් තියෙනවා. So in this motion, the motion is expressed displacement and time. And we already know what displacement is, right? So here, බලන්න ළමයි, every second. So when the time is increasing by 1 second, how much is the displacement increasing? When the time is increasing by 1 second, how much is the displacement increasing? How much is the displacement increasing? Hmm? When the time is increasing by 1 second, how much is the displacement increasing? Okay, yes. 3 meters. Here, the time is again increasing by 1 second. How much is the displacement increasing? How much is the displacement increasing? 2 meters. Time is increasing by another second. How much is the displacement increasing here? 4 meters. time is increasing by 1 second, how much is the displacement increasing? 3 meters. Every second, the displacement that has increased is not uniform or it's not constant. But if we talk about another motion, okay, let me show you a different type of a motion like this. ඒකට මම වෙනම draw කරලා පෙන්නන්න. බලන්න මෙන්න මෙහෙම එකක්. Here time in second and here displacement in meters. So when the time is 0, displacement is also 0. When the time is 1, displacement is 4. When the time is 2, displacement is 8. When the time is 3, displacement is 12. When the time is 4, displacement is 16. And when the time is 5, displacement is 20. I'm sorry, my table looks a bit odd, but this is how the table goes. Okay. Then make a balance. When time increases by 1 second, how much is the displacement increasing? How much is the displacement increasing? 4 meters. Again, the time is increasing by 1 second. How much is the displacement increasing?
4 meters.
4 meters. 4 meters. When the time is increasing by 1 second, how much is the displacement increasing? Again, 4 meters. The time is increasing by 1 second again. How much is the displacement increasing?
Four meters.
Yes, 4 meters. Again, the time is increasing by 1 second. How much is the displacement increasing?
4 meters.
4 meters. Now, what is the difference between this and the motion that I talked about earlier? බලන්න මෙතන හැම second එකේම displacement එක වැඩි වෙන්නේ එකම amount එකෙන්. One second ළමයි, some of you can't join it seems, no? ඔයාලා join වෙද්දි ප්‍රශ්නයක් ආවේ නැද්ද? Some of you have encountered a problem when it comes to joining. In a banner, Mama Shana's time, make one. Why is this? Okay, I sent her. All right. Oh, worksheet. Lesson 1 එකේ worksheet එක අපි බාගෙට නේද discuss කරේ. ඒක මට අන්තිමට last at around 9 PM. Can you remind me, Sasheli? 9 PM වගේ විදි remind කරන්න කොතර අපි අන්තිම ටිකේ ඒක discuss කරමු. We'll continue this and then at the end we'll discuss. Okay. Now here every passing second the displacement has increased by 4 meters. 4 meter, 4 meter, 4 meter, 4 meter, 4 meter. මෙන්න මේ වගේ වෙලාවට අපි කියනවා velocity වලට we call it uniform velocity. Why? Every passing second the displacement is increasing by equal amounts. Okay, so here every second the displacement increased is equal. Therefore we call this uniform or constant velocity. Okay, ඔයාලා මතකයිද ළමයි we discussed the same in uniform speed or constant speed. Uniform speed hari constant speed hari එකේ හැම second එකටම distance එක වැඩි වුණ එකම amount එක, so we called it uniform speed or constant speed. In the same way, every second the displacement increasing is the same, so we call it uniform or constant velocity. Okay? So how do you find the uniform velocity? Ara vidiyatama thamai. Okay? Uniform velocity equals displacement divided by time. Displacement here is, this is uniform velocity, no? So you can get any displacement. What total displacement that is 20. The total time is 5. So you can get 20 meters divided by 5 seconds. And 20 divided by 5 would be 4 meters per second. Uniform velocity not a කැමැතික ගන්න පුළුවන්. මම මේක චුට්ටක් පල්ලෙහාට move කරන්න ළමයි, otherwise I don't have enough space. එහෙම ඔයා මුළු එකම කැමති නැත්නම් you can just consider the first 2 seconds. First 2 seconds වල displacement එක 8. In the first 2 seconds the time is 2. So 8 divided by 2 also you get the same answer, 4 meters per second. එහෙම නැත්නම් ඔයාට පුළුවන් වෙන එකක් ගන්න. Like you can get the first 4 seconds. First 4 seconds will displacement like 16 meters. Time is 4 seconds. 16 divided by 4 also you get 4 ms minus 1. Since this is uniform velocity lamai, wherever you take, whichever section you take, when you divide the displacement by time, you get the same value, which is our uniform velocity. එකෙන් ළමයි velocity එක වෙනස් වෙන එකම velocity එක තමයි තියෙන්නේ. Is that clear to all of you? Is that clear to all of you ළමයි? Others? Juanita, come on. If you have questions, you can ask, of course. But if it's clear, let me know.
Can you explain it again?
I'm sorry, I didn't hear.
Can you explain it again?
Yes, of course. I'll explain it one more time. So here what happened was that every second, up is 0 in 1 second, 2 second, 3 second, 4 second, 5 second. Likewise, every second, we are going to measure the displacement of a particular object. I have to give something at the top for y'all to write. Anyhow, every second, the displacement that is increasing is the same. 0 in the first second, the displacement is 4 meters. From first second to second, displacement increased is again by 4 meters. From second to third second, the displacement increased is again 4 meters. From third second to fourth second, displacement increase 4. Then fourth to fifth second, again the displacement increase is 4. The increase of displacement is the same throughout. Values venas, but හැමලෙම 4 වලින් තමයි වැඩි වෙලා තියෙන්නේ. 4, 8, 12, 16, 20. ඒ වගේ වෙලාවට since the displacement increased every second is equal, මෙතන එන velocity එකට අපි කියනවා uniform velocity. Or we call it constant velocity. So මෙතන කොහොමද අපි uniform velocity එක හොයන්නේ? ඔයා කැමති නම් මේ මුළු displacement එක අරගෙන, the total displacement here is 20 meters නේ. If you consider this particular, don't touch the board, huh? If you consider this particular instance, displacement is 20 meters, time is 5 seconds, so 20 divided by 5, you get 4 meters per second. එහෙම නැත්නම් ඔයා බැලුවොත් මෙතන, if you consider this instance, displacement is 8 meters, time is 2 seconds. Again, 8 divided by 2 is again 4 ms minus 1. Or if you consider this moment, displacement is 16 meters, time is 4 seconds. So 16 divided by 4, again 4 ms minus 1. Likewise, whatever the spot you choose, when you divide that displacement by time, always the final answer is the same. 4, 4, 4. It's always the same value, uniform velocity. එකම velocity value එක තමයි තියෙන්නේ. Chitul, is it clear?
Yes, miss.
Okay. Pratiksha and Shashinta, are you all new today?
Yes, miss, I am new.
Okay, all right. So since you and who else? Sanjana. Sanjana and Pratiksha, can you drop your WhatsApp numbers in the chat box? In the Zoom chat, drop your WhatsApp numbers.
Okay, miss.
Okay, all right. So, is this clear to everybody, Lamai? Any questions? Any questions? Okay, then let's
Miss,
start.
I dropped it.
Okay, Pratiksha, got it. So, all the newcomers, since it's your first day today, you stay for the class today, and by the end of the class, within today and tomorrow, let me know whether you will be continuing the class or not. Okay, Pratiksha and Sanjana, is it clear? Okay. So,
Yes.
okay. Consider the following motion of an object. කියලා දාලා මේක ලියාගන්න. Quickly write this one. Make it fast. Quickly write.
Miss, do we have to draw that chart?
Yes, you have to draw this table. මෙන්න මේක ලියලා. You write this one, then draw this table, and then write this part. Make it fast, huh? Quickly write, Lamai. Abbas Hassan, are you a newcomer today? Abbas, are you a newcomer today? You can even let me know in the chat. Okay. So, I'll let you know what we were doing. We finished the first lesson and we are now in the second lesson. In the second lesson also, we are somewhere in the middle. Right now, we are discussing velocity. So this part might not make sense to you, but we will soon be moving to the next part. Then it will be a bit more clearer. And also, since it's your first day, stay for the class today. And at the end of the class, let me know whether you will continue or not within today and tomorrow. Whether we will continue the class or not. Okay, Abbas?
Okay.
Okay, and also drop your WhatsApp number in the chat box. You can even personally send it to me in the chat box. Okay, quickly write this, Namai. Once you're done writing, give me a thumbs up. Then we'll move on to the next part. Others done? If you're done, give me a thumbs up, please. Others? Not yet. I will give you like 2 more minutes. I'll give you 2 more minutes. Sorry?
I have a question.
Yes, Ashwini. Yes, go ahead.
When you get the answer, like for example, 20 meters divided by 5 seconds, the answer is 4ms minus 1, right?
Yes.
So where do you get that minus 1 bit?
එතන වෙන්නේ දැන් මෙතන තියෙනවනේ in the displacement we measure it using meters, time we measure using seconds, right? Then when you divide 20 by 5, the number you get 4. Unit එක ගත්තහම මට මෙම 4 කියලා මෙතන unit එක m divided by s කියලා තියන්න බැහැනේ. So what I do is I bring this s to the top. Now here this s, it has nothing, but nothing කියන්නේ මෙතන power 1 එකක් තියෙනව නේද? Any number, අපි එක දැම්මේ නැති වුණාට anything, there's always a power. If you look at this 4, there's a power 1. එක අපි ලියන්නේ නැහැ. If you look at this m, there's a power 1, we don't write it. If you look at this s, there's a power 1, we don't write it. Is that clear, Sashali, up to that point? Okay, එතකොට මම මොකද කරන්නේ? මෙන්න මේ s එක උඩට ගේනවා. When I bring this s to the top, එයාගේ power එකේ sign එක මාරු වෙනවා. Here it had s to the power 1. That one, when you bring it to the numerator, that 1 becomes minus 1. So s minus 1. Anything when you bring, if it's in numerator, if you bring it to the denominator, power එකේ sign එක මාරු වෙනවා. Denominator තියෙන එකක් numerator අරන් ගියොත් again sign එකේ power එක මාරු වෙනවා. මෙයාගේ denominator තියදී sign එක තිබ්බේ plus 1 නේ, 1 means plus 1 නේ. So when you bring it to the numerator, එයා minus 1 වෙනවා. Okay? Is it clear?
Yes, teacher. Thank you.
Okay. So speed, velocity, දෙකේම unit is meters per second, ms minus 1. Okay, I think we can move on. Let's look at this one. Now, this is what we started by discussing, no? බලන්න 0 ඉඳන් 1 එක second එකක් වැඩි වෙනවා. Displacement එක වැඩි වෙනවා 3 meters. 0 ඉඳන් 3 වෙනකම්, that is 3 meters. Then the time is increasing by another second. Displacement is increasing by 2 meters. 3 meters to 5 meters means 2 meters has increased. Time is increasing from second to third second. That means 1 second වැඩි වෙලා. Displacement එක වැඩි වෙලා 4 meters වලින්. 5 to 9 means 4 meters. Then මෙතන ඉඳන් මෙතනට තව second එකක් වැඩි වෙලා. එතකොට displacement එක 3 meters වලින් වැඩි වෙලා. 9 meters to 12 meters means 3 has increased. Here now, if you look at this previous example, every second the displacement has increased equally. Plus 4, plus 4, plus 4, plus 4, plus 4. Displacement has increased equally. But මෙතන මොකද වෙලා තියෙන්නේ? Displacement has not increased equally. මෙතන plus 3, මෙතන plus 2, plus 4, plus 3, likewise. Therefore, here, every second, the displacement increased is not equal. එහෙනම් මේ uniform velocity ද? Can we call this uniform velocity then, ළමයි? Can we call this uniform velocity?
No.
No. Uniform velocity na හැම second එකේදීම displacement එක එකම amount එකකින් වැඩි වෙන්න ඕනේ. Therefore, this is not uniform or constant velocity. What do you think I should, how do I find velocity here? ඔයගලන්ට මතක කියන්නේ අපි speed වලත් මේ වගේ එකක් කතා කරා. previous week when we were talking about speed, we discussed something like this. Here, how do I find velocity? Which velocity do I find? If this is not uniform velocity or constant velocity, what kind of a velocity do I find here? I have to find the mean velocity. Therefore, we have to get the mean velocity. ළමයි speed වලත් අපි මේ වගේම කතා කරා. Every second, if the distance, speed not distance, if the distance increased is the same, we call that uniform speed or constant speed. Every second, if the distance increased is not equal, we cannot call it uniform speed or constant speed. So we just found the mean speed. In velocity also, every second, if the displacement increased is equal, we call it uniform velocity or constant velocity. Every second, if the displacement increased is not equal, we cannot call it uniform velocity or constant velocity. We call it mean velocity. We call it mean velocity. කොහොමද අපි mean velocity හොයන්නේ ළමයි? Do you all remember how to find mean speed? How did we find mean speed? කියන්නේ මම last week ඉගෙන ගත්තේ ඔමේ. Mean speed.
Total distance traveled divided by total time taken.
Total distance traveled divided by total time taken. Sorry. Now give me 1 second. Okay. So mean speed means total distance traveled divided by the total time. Now mean velocity කියන්නේ total displacement divided by total time. Mean speed was total distance divided by total time. Mean velocity means total displacement divided by total time. මොකද ළමයි බලන්න හැම සෙකන්ඩ් එකේම displacement වැඩි වෙන්නේ එක එක විදියට. ඒකින්ද මට uniform velocity කතා කරන්න බෑ. So what I talk about is mean velocity. එතකොට every second කොච්චරක් වැඩි වෙනවද කියන එක it's not relevant to me. I don't care about how much the displacement is increasing every second because I only want the total. What is the total displacement here, lamai? What is the total displacement here? Twelve meters. What is the total time here?
4 seconds.
4 seconds. So 12 divided by 4, what is the mean velocity then?
3 ms minus 1.
Yes, 12 divided by 4 is 3 meters. Me second order s minus 1 vena. That is 3 ms minus 1. If every second the displacement increase is not equal, we just find the mean velocity. That is pretty easy. Because mean velocity is total displacement divided by total time. If the hammer second because we are only getting the total. Is that clear to everybody? Please give me a thumbs up. Yes, worksheet at the end of the class we'll discuss. Worksheet MCQ I think we only have the short answers. So we will discuss it at the end of the class. Okay, Lama. Then let's quickly write this one. Quickly write. Now, y'all are still at the very beginning of grade 10 no? So, still, still it's the beginning of grade 10. So I can take it pretty easy and slow and all that. So, that makes sense. Ogalang damma mo levels gana ලොකුවට what even known and දැන්ට කරගෙන යන්න ටික විතරක් කරාම ඇති. හැබැයි මට ඕගොල්ලන් මේන්ලිම learn කරන්න ඕනේ practice කරන්න ඕනේ skill එකක් තමයි speed. Your writing speed. Because over the years, now I've been doing this for like 6 years, I have encountered many different types of students, right? සමහර කට්ටිය මුල ඉඳන්ම හරිම slow ලියන එක. They're right. I might have told this before as well, but ඊට පස්සේ classes join වෙච්ච ළමයිනුත් ඇති. So let me tell this again. Some students are slow. Slow කියන්නේ හිතන එක නෙවෙයි, මම කියන්නේ ලියන එක. Their writing is pretty slow. Himming ලස්සනට round කර කර එහෙම ලියනවා. ඒක වැරද්දක් නෙවෙයි. But for O levels, that speed doesn't fit. I don't know. ඔගොල්ලන් දැම්ම ඉඳන්ම slow නම් ලියන්නේ. ඔගොල්ලන් හිතයි කමන්නේ මම එහෙම slow ලියනවා. exam එකේ මට ඉක්මනට ඕන ලියන්න පුළුවන්. එහෙම කරන්න බෑ. When you are sitting for the exam, you have a certain mindset. You are stressed out, you are a bit anxious and nervous, and it might be a completely new environment, right? So exam එක ලියද්දි ඔයාට හැමදේම ගැන හිතින්න බෑ. ඔයාට හිතන්න පුළුවන් exam එකේ එන questions ටික විතරයි. අඩුම තරම ඔයා ලියන විදියවත් ඔයාට එහෙම ලොකුවට එච්චර note වෙන්නේ නැහැ. හැබැයි ඔයා දැම්ම ඉඳන්ම speed ලියන්න practice කරොත් it will become a habit. Then at the exam automatically you will write faster. So I know some of you have good speeds. Others also should work on your speed. It's just something you need to work on. There's nothing wrong with that. හැබැයි එහෙම වුණත් ඔයගොල්ලෝ slowly යන පුරුදු වුණොත් මොකද්ද වෙන්නේ ළමයි? exam එකේ ලියන්න වැඩියෙන් time යන හින්දා හිතන්න යන time එක අඩු වෙනවා. ඒ කියන්නේ ඔයාලට හිතන්න time ඉතුරු වෙන්නේ නැහැ. Let's say you have 3 hours. ඉක්මනට ලියන ළමයි ඉක්මනට ලියලා ඉතුරු time එකේ හිතනවා. But slow ලියන එකනා slow ලියනවා. එතකොට හිතන්න time එක මදි වෙනවා. Okay, so that is actually one of the reasons why ගොඩක් time restrict වෙන papers ගත්තොත් science වලටත් වඩා maths වලට තමයි ගොඩක් time restrict වෙන්නේ. And like papers like සිංහල වගේ ටිකක් වැඩිපුර time යන papers. එතකොට ඔයගොල්ලන්ගේ writing speed එක වැඩි නම් you have half of your problem solved. ඊට පස්සේ වට එතකොට හිතන time එක space එක ඉතුරු වෙනවා. That's why I want you all to හිතලම consciously speed ලියන්න if you think you write a bit slow. Not that there's anything wrong, it's just that for the exam එක ගැලපෙන්නේ නැහැ එකයි. Okay? ලස්සන ලිව්වට කමක් නැහැ. අර ඕනවට වඩා මුතු කැට වගේ අකුරු ලියන්න ඕනේ නැහැ. Okay, quickly write. While you write this, give me a minute, lamai.
Done, teacher.
Okay. Others? Okay, so there are some of you still writing. So I'll give you like 1 more minute. I'll give 1 more minute. Shanaz, were you able to join? Shanaz, can you hear me? Okay, for those of you who are writing, I'll give you like 1 more minute. Yes, Shanaz, can you hear?
Miss, normally I
Yeah.
can join.
Did you can ekak link එකෙන් join කරන try කරාද? And the other one is without the link, did you try joining using the meeting ID and passcode? Did you try both the ways?
Yes, Miss. Yes.
So one thing, Shanaz, I would suggest is after the class today, try to update your Zoom. Update කළ බලමු එක හරියයිද කියලා. You're also joining tomorrow's maths නේද?
Yeah, yeah.
So tomorrow, let's see. අපි චුට්ටක් මට message එකක් දාන්න. අපි විනාඩි 5ක් විතර කලින් class එක පටන් අරගෙන ඔයා කලින් join වෙන්න. Then we can test it. Okay?
Okay, Miss. Okay.
So we'll start the class at around 6:50, 6:55, just you and me.
Okay.
Just to sort your problem. We'll see.
Okay, Miss.
Okay. Other I will definitely send you the recording. Previous week also you encountered a similar problem. Did you ask for the
Miss,
recording?
every week I have this problem, Miss.
What?
Every week I have this problem that I can't join.
Exactly. That's so we'll try updating. Today after the class, update your Zoom before tomorrow's class. Huh?
Okay, Miss.
Okay. So we'll try tomorrow. And just send a reminder on WhatsApp and request for all the previous recordings that you may have missed. Okay?
Okay, Miss.
Okay.
Miss, can you show what did you all do now?
We did this and this only. For this, you can keep like if it's a CR book, half a page would be enough. For this also, another half a page would be enough.
Okay, Miss.
Okay. Others, can we continue? Dana ඇති වෙලාව. Anybody who needs more time to write? Okay. That is enough. Now, we learned about uniform velocity, and then we learned about mean velocity. So, okay. We'll try a small question.
Science textbook
We'll try a small question, Lamai. I'll go to page. No, I'll give you a question. Q කියලා question එකක් ලියා ගන්න. Given below, I'll type as well. Sorry, wait. Of a student from his home to the school. I might need some time to draw this table. Please be patient with me. And also, if I'm talking a bit weirdly, I'm sorry. I have blisters inside my mouth, so it irritates when I talk. That's why sometimes all my words get jumbled up when I'm speaking. If it annoys you, I'm sorry. Just be patient with me for today. Okay. Time. displacement 0 I'm going to extend the table a bit. 9 and 10. So we have a motion that spans for 10 seconds, right? Then underneath that I will do some questions. You can write the question, write the answer, then write the next question. Because I will anyways be typing the questions in the board. Huh? Space space so that's why I'll just type the questions. As I said, you write the question, you write the answer, then you write the next question, write the answer. Of course, you have to write the question because this is a question that we're giving in the class. Textbook exercises now question but if I'm giving a question that is out of nowhere, then of course you have to write the question. Okay. ළමයි මම චූටි දෙයක් තව කියන්නම්. ඒක මම කියන්නේ එක අපි මෙතනද ඩිස්කස් කරමු. දැන් velocity අපි කොහොමද ඒ velocity we said velocity is equal to displacement over time කියලානේ. I'm going to give you like a shortcut to find velocity. That would be easier for you. Okay. Velocity හොයද්දී මෙන්න මෙහෙම කරන්න. Mama last week උගන්ට note එක දෙද්දී did I give as velocity equals displacement over time or did I give velocity equals change of displacement over time? බලන්න ඔයගොල්ලන්ගේ note එකේ කොහොමද තියෙන්නේ කියලා ළමයි?
Velocity equals displacement divided by
Just displacement divided by time, no?
Yes.
Okay. So I'm going to give a small shortcut here. ඒක දැනට ඔයගොල්ලන් කොහෙන්වත් ලියන්න ඕනේ නැහැ. මේ questions ටිකට answer කරද්දී විතරක් ඒක use කරන්න. At the end I will give a separate part for that. Huh? Now velocity equals displacement over time නේ. මේක අපිට හොයන්න ලේසි if I take it as change of displacement over time. Change of displacement over time. Change එකක් කියන්නේ කොහොමද හැමලෙම? ඒ කියන්නේ හිතන්න let's say now I have a displacement of 3 meters. Then I walk a bit and then now I will have a displacement of 5 meters. Initially I have 3 meter displacement, then I have 5 meter displacement. So the change is what? 2 meters. Change can be venasa. That is 2 meters. Change in displacement කියන එක හොයන්න ඊට වඩා ලේසි ක්‍රමයක් තියෙනවා. You can write final displacement minus initial displacement divided by time. මේක මම පස්සේ වෙනම section එකක් දෙනවා. දැනට just use this for questions only. මම මේ දීලා තියෙන question එකේ answers දෙන්න මේක use කරා. Velocity equals final displacement minus initial displacement divided by time. Later I will give a separate note for that. Is that clear to all of you? මම කියපක තේරුණා නේද? Okay. What is it, Sasheli?
Explain again, please.
I can't hear you.
Explain again, please.
You're asking me to explain again, right? Yeah, okay. මේ ඔයාගේ පැත්තේ volume එක අඩු වෙලා හෙන්නේ ඒකයි. But yeah, okay. So initially I told you මම ඔයාලට මුලින්ම velocity equation එක දුන්නේ velocity equals displacement divided by time. අපි නිකම් මෙහෙම කිව්වට when we are doing questions නිකන් displacement divided by time කියලා questions වල answers වන්න අමාරුයි. So a better way for that would be velocity equals change of displacement divided by time. If I have a displacement of 3 meters now, and then in a bit I will have a displacement of 5 meters, what is the change there? මුලින්ම 3 meters, ඊට පස්සේ 5 meters, then the change is 2 meters. වෙනස, the difference, right? ඒක ඊට වඩා ලේසි. හැබැයි ඊටත් වඩා ලේසි තව ක්‍රමයක් තියෙනවා. මොකක්ද? Change එක කියලා කියන්නේ වෙනසනේ. So how do I get the change? Final displacement minus initial displacement. That is still the change, right? If I have a displacement of 3 meters now, and in a bit I have a displacement of 5 meters, my final displacement is 5 meters, my initial displacement is 3 meters, so the difference is 2 meters. Then I can divide that by time and get the velocity value. Make a best way to find velocity. Danata for these questions, use this method. Make a venom liaga no na mukadamang I make it a venom note again. Is that clear, Sasheli? Okay. So I'll write the next question. These questions are very important because based on your answer, we are going to learn some more about our velocity and velocity topic. Make it fast. Let's quickly do this. From the three formulas I gave, you have to better to use. Our best option is to use this start one. මෙයාව use කරද්දී පැටලෙන්නේ නැහැ කිසිම දෙයක්. It doesn't get confusing. So better to use the third one. මම third එක ගත්තේ මෙන්න මෙහෙම. Velocity equals displacement over time. Displacement means change of displacement. Change of displacement means final displacement minus initial displacement. So this is the pathway, but the third method is the best method to use. This might be a bit difficult for you, but try your best to get the answer because we will anyways be discussing. This is going to be a learning experience for you. Okay? Hari, karanako. I give you some time. Initial displacement කියන්නේ ජිතුලේ අපි පටන් ගන්න displacement එක. Now let's say now I have a displacement of 3 meters, but in another bit I have a displacement of 5 meters.